This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss about one of the most prominent sorting techniques, insertion sort. Let me give a small intro on what sorting is, what are various types of sortings techniques which we have. So sorting is nothing but arranging the data in either ascending or descending order. The most prominent ones which we might have seen or encountered in your academics are bubble, insertion, selection, quick, merge, shell, heap, and lot more. Okay, here bubble, insertion, selection are just straightforward sorting techniques, whereas quick and merge rely on divide and conquer, and your heap sort is going to use non-linear data structure, which is trees to, or a heap, you can say precisely a heap to sort the content. But now for today's session, our point of concentration is insertion. Let's have a look at a brief overview on insertion sort. So in insertion sort, sequentially we are going to compare the element to one another in such a way that generally we go with the comparison of the elements from left to right, but here from right to left we are going to do. That means I'm going to start my sorting process from the second element and try to go in left direction. The left direction, that is with the elements with lower index value, I'm going to compare and sort it. Right? So the sorter functions, the basic principle is to insert the given element, the basic element that you're going to sort, then that particular iteration to its right position is nothing but insertion sort. Its best, worst, and average complexity is order of n into n, and the memory it is going to use is order of 1, means it does not need any extra space to sort, right? So it is stable and in place. It doesn't need any new values or new spaces, nothing, right? It doesn't need any spaces. Within the list only, it is going to swap the content and it is going to sort and give us a final list. And let's go through an algorithm for the same. So the first step involves comparison of the element in question with its adjacent element. As I said, the second element is compared with the first element, sorted, then the third element with second and first elements, fourth element with third, second, and first elements. In the left direction you are going to search for. So if every comparison reveals that the element in question can be inserted at a particular position, then shift the elements and insert it. You are going to repeat this process unless the whole array is sorted. Okay, I'm going to explain this sorting technique with a simple example. Please do follow this, guys. So I have taken a list of 5 elements. It is an unsorted list: 21, 54, 36, 18, and 29. I'm going to initialize my variables now. So have a look at this one. I'm going to initialize my I, the first index, with the index value 1, and j is equal to I minus 1. This is the initialization. Okay, so have a array is and now my point of concentration is the key element, which is always the element pointed by I. So here key is equal to 54. Now my comparison process starts. While my key value is less than the element pointed by j, and the index value of j must be greater than or at least equal to 0 if these two conditions, that is basically if the key value is less than the element pointed by j, right, then I am going to copy the content of j in j plus 1th location also. I'm going to copy the content of j in j plus 1th location and I'm going to decrement it. Okay, here the key value is 54 and J is pointing to 21. Is 54 less than 21? Condition fails. As the condition fails, the key value is placed in J plus 1 position. What is J plus 1 position? 1 is nothing but J. J is at 0. And if you add 1 to it, it will be 1. So at array of 1, copy the content in the key. The key value is 54. So overwrite it, 54 with 54. So by the end of this point, the result will be in this way. Have a look. 54 is at the index value 1. Now, as we have incremented I, now I is pointing to index value 2. Right? So J is initialized to I minus 1. So J is pointing to index value 1. Okay, so again, the same process I am going to do. Now, key is going to hold the element pointed by I, which is 36. Right? So, again, start the comparison. Comparison between the element pointed by J and the key. So, the key value, is it less than the element pointed by J? If it is so, copy the content in J index value to J plus 1 and decrement J. If not, right, copy the key in J plus 1 position and increment I. Let's have a look. So here key is 36, whereas J is pointing to the element 54. So is 36 less than 54 condition satisfied? So as the condition is satisfied, copy the jth position value, which is 54, in a J plus 1. J plus 1 money in index value 2. That means you are going to overwrite 36 with 54. 36 with 54. So have a look. I have overwritten 36 with 54. And I've decremented J also. Initially, J was pointing to index value 1. Now it is pointing to index value 0. Right? So, let's start. Guys, please do not worry. We didn't lose 36. It is still stored in the variable key. Remember that. Okay? So, while, again, check the condition. While key is less than the element pointed by J, right, and J is greater than or equal to 0. Let's check both. Here key value is 36. We didn't overwrite it or change it, right? So element pointed by J is 21. Is 36 less than 21? The condition fails. As the condition fails, now I have to write the key in J plus 1 position. What is J plus 1 position? J position is at 0. J plus 1 the position is index value 1, where 54 is there. So you have to overwrite with 36. Overwrite it with 36 and increment I. Right? So now your list is changed to 21, 36, 54, 18 and 29. Okay. As you have incremented I, now I is pointing to index value 3. And J is initialized to I minus 1, which is pointing to 2. Right? This is the initialization part. Now let's repeat our process. While key is less than your basic element, right? So when the key is less than the element pointed by J, the key value is 18 and J is pointing to 54. Right. Let's have a look. Key is 18 and array of j is pointing to 54, and the condition gets satisfied. 18 is less than 54. As the condition got satisfied, you have to copy jth element in j plus 1th location. So 18 will be overwritten by 54. Jth location is at index value 2. Its next is, right, 3. So overwrite it and decrement j. Now j will be pointing to index value 1. Right? So now the list changes like this. Right? You did not worry, guys. We didn't lose 18. It is stored in key. So again, let's go for a comparison. Is key less than the element pointed by j? Key value is 18 and the element pointed by j is 36. It's clearly evident 18 is less than 36. The condition satisfies. If the condition satisfies, what you have to do? Copy the element in jth position in j plus 1th position. In jth position, we have 36 and in j plus 1th, we have 54. I'm going to overwrite it with 36 and further decrement j. So j will be pointing to index value 0 now, right? So this will change to this line. Have a look, right? Now, again check. Key value is less than the element pointed by j or not. Here, key is 18 and the element pointed by j is 21. It is clearly evident that 18 is less than 21. As the condition gets satisfied, copy the content pointed by j into j plus 1th location. The element pointed by j is 21. So overwrite this 36 with 21 and decrement j. If you decrement j, it will go out of boundary. That is, it will go to -1. Even if you check, it will say j is -1 out of bounds. This tells us it is the end of the iteration. With the end of the iteration, what we have to do? Simply copy the key in j plus 1th position. What is the value in key? It is 18. So in actually j is -1 ds as we have decremented, and j plus 1 position mane -1 plus 1, which will lead to a of 0, which is equal to key. In 0th location, you are going to copy key. What is the key? 18 is the key. Right? This is how we are going to overwrite. Got my point? Very good. So this is the end of the second iteration. By the end of the second iteration, we are going to increment the I value to start a new one. Right? So when we increment I, it will point to the last element 29. As it is pointing to the last element 29, j will be pointing to one index value less than it. That is pointing to index value 3. Let's repeat the same process. Here the key value is 29 enough, and let's start the comparison. Now, is the key value less than the element pointed by j and the value of j is greater than equal to 0 or not? Let's check it. So is here the key value is 29 and the element pointed by j is 54. Is 29 less than 54? Condition satisfied. As the condition got satisfied, copy the content of j, which is 54, in j plus 1. That means overwrite 29 with 54. Okay, and decrement j. If I decrement j, it will be pointing to index value 2 now. Right? So this is going to convert in this way. Have a look. Now j is pointing to 36. Need not worry, guys. 29 is stored in key. We are searching for the right place for the key value with every iteration, right? So it's safe. Again, let's start the same process. Is the key value less than the element pointed by j? So here the key value is 29 and element pointed by j is 36. Is 29 less than 36? Yes, it is less than, condition satisfied. So copy the content of j in j plus 1th location. So 54 will be overwritten by 36 and decrement j. If I decrement j, j will be pointing to index value 1 now, right? So this is how it is going to change. Have a look. This is the current scenario. Again, compare between the element key and the element pointed by j. So key is 29 and the j is pointing to element 21. Is key less than 21? The condition fails. 29 is not less than 21. So as the condition fails, copy the key value in j plus 1th location. So what is the key value? 29. Copy in j plus 1. Mane at index value 2 you are going to copy it. At index value 2 we are going to copy it, right? So this is how. Then once you have copied, you have chosen a right place to place key, you have to increment I value. Okay, so if you increment I value, what will happen? It will go out of limits, right? As it goes, here is the process, guys, the condition which we last got failed. And if I increment I, it will point to an element which is out of the list, right? So this, there goes the end of my logic, and the final list is in your hands. So final sorted list is 18, 21, 29, 36 and 54. It's a very simple logic, guys. Always start your sorting technique with the first index. Generally, in bubble and selection, you might have seen that you are going to start with the 0th element. No, here you are going to start with the second element, and you are going to go in a reverse direction from right to left to find a place or the correct position for the element pointed by I. The element pointed by I will always be a key value, right? So this is a short note on insertion sort. We have seen what is the basic funda of insertion sort and algorithm with an example, with an explanation of the example. Let's see a Python code for the same. Hello guys, this is your insertion sort technique, right? We have seen what insertion sort is basically, and when I've explained you with an example also. Let us go with a Python code on the same. Okay, this is a Python shell where I'm going to write a script for insertion sort. Let me open a blank one. Okay, this is the page where I'm going to write insertion sort. Let me put the heading. Guys, these comments are very, very important. Very, very important. Right? Why? Because a novice, anybody who opens the script must be able to know what this script is meant for, what he's supposed to give, and what he's going to gain from it. He must be able to figure it out, right? So the comment section is very important. So let me design the driver code first so that we can, based upon the driver code, let me write the function. So I always prefer starting with the driver code. I don't say that I'm going to write the complete driver code. Wherever I need the modifications, I'll be keep on doing. Okay, let's follow this. So I'm going to write the driver code first. So here, first of all, I'm going to read the number of elements I want to sort. I'm going to read enter the number of elements. Okay, enter the number of elements which you want to sort. Okay, let the name of the list be ARR, and I'll read n a list of n elements which are unsorted in nature. Okay, so list map of, okay, the type will be integer, input function, and I'll see that they are split by space. So map function needs two parameters, guys. I hope you know that. One is the data type, which type of elements you are going to read, and the other is what you are going to read. And if you want, you can give a split saying that a space, a split function. I've taken even any symbol also you can take and split, but in generally space is enough, more than enough, guys. Okay, there ends my list. To concatenate or to break my list into the first n values, I'm going to use my slicing operator. Okay, I'm going to consider only the first n elements. Okay, these are the two inputs which I need. One is the number of elements I want to sort, and the next is the list of elements I'm going to read. Next comes my function call. Guys, always give a relevant name. I've seen many students who give irrelevant names or their names as the function names. Ultimately, you are going to get confused why you have written. After a few days, we open the same script and you will find why I have written this function. What is the purpose of this function? So always remember that the function name should be relevant to the functionality. They must go in hand. Okay. So as my purpose of writing this function is insertion sort, I've named it as this. Okay. And by the end of my function call, I just want to see how the sorted list looks like. So sorted list. I'm going to just print the list. Okay. So this is my basic function call. Okay, so generally it's better to use comment lines, guys, so that the one who reads it for the first time might be able to understand it. Okay, so now I have finished with my driver code. Now I would like to write the function definition. Let's start. Def insertion sort, and the only parameter I have passed to it is the list which I want to sort, right? So I've passed that. Now I want to run from all the elements, but starting with the second element. So be very specific with the starting point of my range, which is 1. If I don't give the starting point, by default it will take 0, which I don't want. So I want to initialize my I with the second element. That is the element at index position 1, right? So I'm going to run throughout the list. So my stopping point is, if n is this size, then n minus 1, right? So I've taken a loop with I as a controlling parameter, which starts from 1 and goes till the end of the list, right? So what is the key? What did I tell you? Key is always the element pointed by I, right? So have to initialize J one step behind I, right? So what was the conditions which we have used? While your key is less than the element pointed by J, and your J value is greater than or equal to 0, which gives a limiting to J so that it does not cross the left boundary of the list. If these two conditions prevail, then array of j plus 1, right, is equal to array of j. Copy the content in a jth index value to j plus 1th index value. Copy the content and decrement j. So j equal to j minus 1. So decrement j. Okay, so you have to continue. This loop is going to run until unless one of these conditions fails. Either key value must be greater than the element pointed by j, or if j crosses its left boundary, goes with the negative index value, then it is going to break. Once this happens, it tells you that it is the end of the iteration. So once this iteration ends, simply make whatever the content in a j plus 1 is there, copy the key into that. So I'm going to save it with a relevant name, which is insertion sort. Okay guys, let's have a look at the code which we have written. The functionality, this is nothing but your function definition, and it is to run. Your I value is going to run from 1 to the final index value, and these are the initialization part, where initially key holds element pointed by I, right, and j is always one step behind j, one step behind I. Okay, so this is the process. I'm going to compare while key value is less than j and j value is greater than or equal to 0. I'm going to copy the content in ith index to I plus 1th index, and I'm going to decrement j. Once one of these two conditions fails, I'm going to copy the key value in j plus 1th location as the final node or the final step of that particular iteration. Okay, and I've saved this program also. Let me check once. Right, let me run this one. So how many elements? Say 5 elements. Let me take some random elements, guys. So this is the sorted list. 1, 2, 3, 4, and 5 is the sorted list. Right? Okay, let me rerun it. So let me take some 9 values now. 5, 4, 6, 3, 7, 2, 8, 1, 9. Just scrambled 1 to 9 in this order. That's it. So let me check. Yes, it is working. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is nothing in short here. Insertion sort. Let me take you to the program once again. Let's have a look at this one, guys. It's a very simple one. I've started designing it with my driver code, where I have read the first of all the number of elements I'm going to sort, and taking that as my slicing point, I have read a list. Then goes my function call. I have called the insertion sort. Then I have printed the final list, sorted list. With the function call, the control will break and go to the function definition, where I'm going to run from the first index value to the final index value, and with every iteration I'm going to compare the elements which are on the left side of my control. Okay, and I'm going to swap the elements. Remember, the key always holds the element pointed by I, and j will be one step behind I. Okay, so this is the very small funda you have to remember, guys. Very simple one, and this is one of the prominent insertion sorting technique which can be used as so, and it can embed it in any huge sorting technique also. As you have seen that its time complexity is high, whereas I'm comparing the elements continuously, right? Time complexity is high. So if you have handful of elements, then its complexity is not going to be too high. It is not going to be a problem for you. But if the number of elements rise, it will show its ill effects. The amount of time required to sort is going to raise. So to overcome that, see that you use it when the number of elements are less, and you embed it as a part and parcel of the system if you are working with a huge sorting technique, right? So guys, please follow me, and in the previous videos I have even demonstrated selection and bubble sort, and in near future I'm going to publish quick and merge sort also. Do follow the channel. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.